Hello and welcome to another IoT Central webinar. I am Sophia Ansley. I would first like to thank floLIVE for being our sponsor. This webinar is titled, What Happens When Qualcomm Aware Trackers Meet floLIVE Connectivity on a Thales eSIM. Now I would like to turn the webinar over to our host and speakers. Let's get started.
Good morning, good afternoon, good evening, and welcome everyone to this exciting webinar talking about Qualcomm trackers and eSIM and floLIVE connectivity. We're really delighted to have you all with us. My name is Sarah Brown. I'm Executive Vice President of Marketing at floLIVE, and I'm joined today by Simon Isikoff from Qualcomm, Stefan Keklas from Thales, and Curtis Govan, my colleague and President of the Americas at floLIVE. Just a few housekeeping items. We have the opportunity to engage with your questions. If you will just be sure to put your questions in the Q&A, which you might have to press that little three-dotted more button on the top of your interface here to get to it. But if you enter your questions there, I will see them. And we will parse them out to the gentlemen who are speaking. If we're not able to get to your questions, don't worry. When they're recorded in this Q&A box, we can follow up with you after the session. And with that, I will let Simon take the lead.
All right. Thank you, Sarah, and thanks everyone for joining the webinar. So my name is Simon Isikoff. I'm part of the Qualcomm IoT Business Unit, Product Management. To start off, I'd like to give you a very brief introduction of Qualcomm. We just celebrated 40 years of innovating technologies that the world loves. We've powered the mobile revolution, redefined connected processing, and now enabling intelligent edge computing everywhere. Next slide, please. We have, thank you. We've been focused on three key types of technologies across various industries: unrivaled connectivity, high performance, low computing, and leading edge AI. You can see various industries. I'll deep dive today into industrial IoT in particular. So in the next slide, you can see our portfolio for industrial IoT. At the bottom is the foundation that everybody's more or less familiar: 4G, 5G modems from Qualcomm, Wi-Fi or Bluetooth, SoCs, location, and other SoCs. But on top of it, we provide stack and tools that enable various verticals that you can see on the top. Trackers, asset trackers is one that we'll discuss a bit more in detail, but it could be point of sales, body cameras, or many other. One of these tools is the Qualcomm Aware platform. Next click, please. The Qualcomm Aware platform, and maybe in the next slide we can deep dive into the platform itself. It's an IoT cloud platform that enables, next slide please, yes. It's an IoT cloud platform that enables access to device via cloud REST APIs that you can see on the right. The platform enables various verticals, and it's comprised of various services, and although we have enabled a couple of vertical end-to-end devices, we'll see one of them in the next slide. The cloud goal is to enable the ecosystem of our partners to build their own devices using modules, using modems, or downloadable Aware SDKs into any of operating system in order to be able to get insights into their fleet of devices, where the device location is, what's the device health status, and others. One of the key services inside the platform is global connectivity. Next click, please. As we build the global connectivity together with our partners, floLIVE, Thales, we were focused on a few important aspects. Next click, please. One of them is global connectivity. We were looking especially for asset tracking to be able, with one single hardware SKU, low-cost single device, to be able to provide global connectivity to support shipments from Asia to Europe, from East Coast in US to West Coast, India, and many other markets. So one single hardware SKU, that means many RF bands that the modem has to scan. Then there is a trade-off. How do you achieve that using low power consumption? And we spend a lot of time and effort with our partners to optimize scanning, SIM interaction with the modem in order to provide a single hardware SKU with global resilient connectivity. Security and managing the connectivity end-to-end were two additional very important factors. So in the next slide, I'll show some details about one of the devices. This is one example device. Again, this is built by Qualcomm with our partners. It is based on the Qualcomm LTE Cat1 bis modem, QCX216. So the Cat1 bis modem enables us global roaming using an eSIM from Thales and floLIVE connectivity. So the device comes with out-of-the-box connectivity, and you can see it has a very small battery, 200 milliamp, but it allows milliamp hour, but it allows more than 500 pings to the cloud. Depending on the periodicity, you can easily achieve 20 days or more of battery life before recharging the device. It's a credit card size tracker, so you can imagine exactly the size of credit card in your pocket. And you can stick it on a box, you can stick it in an envelope, and it allows you to do package tracking. But we've seen our customers come up with many other use cases to allow asset tracking for various places in the globe. You can see we have included a barcode that allows you to get additional information about the device. Next slide, please. Okay, so before I hand it to Stefan, that will deep dive into eSIM, I do just very briefly want to capture. In the previous slide I mentioned, we included an eSIM. eSIM is an embedded SIM. It's a small surface-mounted chip that is mounted on the PCB of the device side by side with the modem. That revolution, moving from removable large SIMs to eSIM, happened in the last 10 years, probably gradually. The eSIM may come with remote SIM provisioning. That's when it's called EUICC. And SGP.32 is one of the remote SIM provisionings that my colleagues will go into details. And the industry is moving fast into integrated SIM. Inside the modem itself, the Qualcomm modem, there is a secure enclave area, so very small isolated area where we allowed securely to load the SIM-OS and enable an MNO and MVNO profile to provide global connectivity. All that is driven by reducing cost, increasing the lifetime of your device, and simplification. So again, having single hardware SKU that allows you to get global coverage. With that, I'll hand it to Stefan from Thales, please.
Thank you, Simon. It's great to be here. Maybe let's start very quickly about to give a few words about Thales. So we are a global technology leader. We're operating on three different core business segments. And one of them is cyber and digital. This is where we provide connectivity solutions and security solutions for IoT, the IoT and the consumer markets. In terms of IoT, we are a number one provider of eSIM solutions. We have an extensive experience in deploying secure hardware-based root of trust, like embedded SIMs, like embedded secure elements. And we also have advanced cybersecurity capabilities after the acquisition of Imperva last year. So let's dive into the matter now. On the next slide. So like Simon said, we have cellular IoT that is moving from SIM to eSIM. So why are we talking about cellular? Because it's a sizable amount of the IoT today. IoT is mainly, essentially, I would say, wireless today, and cellular represents a sizable amount of these connected devices. So why are they moving from this SIM technology to the eSIM? So first of all, you need to have a SIM functionality inside a cellular device, obviously, to securely connect it to a mobile network. So this is a standardized product that can carry one subscription of one mobile network operator inside. And this creates actually logistics and manufacturing challenges for IoT device makers and the enterprises who want to deploy them. So the multiple versions of the device, multiple stock keeping units, SKUs, is a real problem today. And when you have just one subscription inside a SIM, that means you might face the need to be roaming where the device, when the device is moving or is deployed in a different country or region. So with the eSIM, we solve these problems. This is obviously a standardized product that is also security certified, a very important aspect of it. And because it is programmable, it can hold several subscriptions that can be programmed at the factory or in the field. It allows a full lifecycle management of connectivity. And that means you can move to a single stock keeping unit for your devices and provide the proper connectivity to your device once it is deployed. And it can be a global subscription or a local subscription, depending on the need and where the device is. So next slide, let me explain a bit the evolution of the remote SIM provisioning technology that is behind eSIM. So it's all started with the machine-to-machine technology more than 10 years ago, actually, and for cars, for instance, connected cars. This first flavor of remote SIM provisioning is based on the concept of pushing the connectivity, what we call the profile, to the device. And there are different elements that are required to do that. You have the eSIM server, or called also SMGP, that also subscription, and the another server called SMSR that is in charge of distributing this subscription. They have been created to achieve that. A few years later came the consumer technology for eSIM. So it was about this time providing the same flexibility in terms of connectivity, in terms of distribution of connectivity to consumers, and especially consumers using smartphones, smartwatches. And this time the concept was moved from push to pull. That means as an end user, you select what connectivity you want to have, what connectivity provider you want to contract with to connect your device. And then you pull the device, you request the device to a single eSIM server that is called SMGP Plus in this case. This architecture is much simpler and actually much more easy to use. And now we have the IoT market. So we are. Go back to the previous one, please. Yes, thank you. So the IoT market is about a number of use cases, a large variety of players. So simplicity has become a key need for these players. And this is why the third flavor of eSIM that you can see here has been introduced. So it's a hybrid model, I would say, when you combine the best of the both M2M and consumer world. The profiles, they are still, they are pooled, like in the consumer case, but using with use cases that are similar to the ones that are made possible by the machine-to-machine technology. Because in the IoT, you want to remotely manage devices, fleets of devices. You don't want an end user to manage the connectivity of a given device. So you have, in this case, new elements called the eIM server. This is, for instance, an example of it is the Thales Adaptive Connect server, and that will actually do the remote management of the device in terms of connectivity, and the device through the IoT eSIM will pull will request the download of the connectivity profile to an SMGP Plus server, very similar to the one that we have seen for consumer. So on next slide, let's have a look at the main differences, what it means in terms of approach for the IoT enterprise who wants to deploy their connected devices and operate their services based on these connectivity devices. In the legacy case with eSIM for M2M, it's all about getting the connectivity when it's ready. Meaning, if you want to change the connectivity in your device, this requires a collaboration between the, say, MNO-A, which is the current MNO you're using, and the MNO-B, the new one you would like to use to connect your devices, because they need to be technically interconnected because of this SMSR I was talking about. If they are not interconnected, that means you need time, you need cost to make it happen. And at the end of the day, when the connectivity is ready, it is pushed to your device by MNO-B. On the other hand, if we go to the next slide, you will see in the IoT case, it's all about getting the connectivity right when you need it. That means you want to move from one connectivity provider to another one. As an enterprise, you will control this process of change through the eIM entity I mentioned before. So that means as soon as you get the contract signed with your new provider, then you can pull the connectivity profiles to your device. You have immediate access to connectivity. It's important to mention that in this case, you can access to many mobile network operators on the planet, because you can reuse the DP+ technology that has been already deployed. And it is also, last but not the least, it's also something that you can use whatever the cellular connectivity technology you're using. Even the low power that is designed for constrained devices can be addressed, because this technology has been optimized for the constrained devices, which was not the case for the machine-to-machine one. All right, so SGP.32, which is the name of this technology for eSIM for IoT, is very interesting because it simplifies a lot the way you can manage the connectivity of your devices. Many different use cases can be implemented. You can, for instance, because you can change the connectivity inside the device, you can localize them. You can provide connectivity that is dynamically adapted to where the device is. If you need to provision the connectivity inside the device at the factory stage, it's also possible. Some solutions exist that combine a local private network inside a factory with this technology, where you can actually download the profiles inside the devices before they leave the factory, because, for instance, you want to make sure that once the device leaves the factory, the connectivity is already up and running. Connectivity becomes also more resilient because you can implement automatic fallback in case of the loss of operational connectivity. When the devices are moving, in the mobility case, you can also change the connectivity provider. For instance, if the device goes to Brazil, and it's supposed to stay long in the country, the local regulation will prevent you from doing that. So you need a local connectivity for your device to continue operating in Brazil. So this is a case where you would like to change the connectivity inside the device. Lifecycle is also a key element. If you want, for instance, to move to a different technology, or because your current supplier is now out of business after maybe 15 years, then you still have in your smart meter the ability to move to a new one with this technology. So it brings a number of benefits to the IoT enterprises. Simpler logistics, we spoke about that. Faster device installation is also possible because you can automate a number of things. You can lower your maintenance costs. You can ensure business continuity and provide health flexibility in the choice of your partners and suppliers. All of this is made possible by building on top of the SGP.32 standard additional services where you provide this intelligence, where you can automate the management of the connectivity based on what the device is experiencing. For instance, typical case of the loss of connectivity, you want the device to fall back automatically to another one, or when there's another reason for changing to a different type of connectivity. That was the lifecycle example I mentioned. So finally, this technology needs to be deployed in the devices themselves. So it's important to have in mind that there are two ways of doing that. Of course, you need an eSIM for this that is compliant with the SGP.32 standard, an eSIM for IoT. And then, like in your eSIM-enabled smartphone, you have what we call a local profile system that will help you download the profile from the mobile network operator you have chosen. In the eSIM for IoT, you have the same profile assistant, which is called IPA or IoT profile assistant. And it can be either in the eSIM itself or in the device itself. And there are different advantages depending on what you want to achieve. If you want, for instance, shorten your time to market, to have a package solution that's already tested, you can go for the IPA-E solution, which is fully self-contained in the EUIC, already tested and certified. If you want to have more flexibility in terms of interaction with the device logic, then it's good also to go for the other way of implementing this profile assistant, which is what we call IPA-D for IoT profile assistant in the device. So all in all, this is what you can expect when you decide to go for an SGP.32 eSIM, very well adapted to the new needs of the IoT market. I think if you want to have on the next slide, you will see that you are able to reach us and download more information if you want to know more about what can be done with the SGP.32 solutions. So with that, I'll hand over to Curtis.
Thank you, Sam. Great. First, I'll say greetings. Normally, I would be greeting you from north of Dallas, but due to some travel delays here, today I'm greeting you from Charlotte Douglas International Airport in the Admirals Club here. So a little flexible here. Hopefully, the internet holds up. Looking at what we do from a floLIVE perspective there, as you've heard some from both Simon and Stefan, really we're focused on solving some really key global connectivity problems. And those problems are multi-carrier, multi-country connectivity. That's also high performing when it comes to low latency performance and highly available from a reliability perspective. What we've done to accomplish this is we have first a floLIVE core network infrastructure that's built by floLIVE. We own the technology. Our engineers designed and developed the stack and all of the network elements you can imagine. And then we're combining that with our SIM technology, as well as some really strong relationships with tier one global MNOs and regional MNOs. So the coverage component there. And then we have a distributed core network over 40 different POPs around the world to do that localization, part of which, as Stefan mentioned, in Brazil, as an example there. And then the other piece there is bringing in the satellite component to really combine what you have with cellular and close the gap from a coverage perspective, because coverage is king in the business of IoT. And so this is the fundamental piece that we offer here from floLIVE from a global connectivity perspective. In the next slide, you'll see what we're doing there is really, if you look at the heart of connectivity, we're talking about SIM because it's really important to have that SIM. This enables all of the functionality at the device level that we talked about. As Simon and Stefan both mentioned, first, it comes from a single SKU. And if you look at coverage, when we talk about multi-carrier, multi-country coverage there, this is an example of what we do, what we have capability of doing, I should say, in the US, where you have multiple carriers that are covered by single eSIM. And then behind that, you've got core network infrastructure that is completely redundant. So within the SIM technology, you have the ability to automatically switch if there's a failure. Obviously, you have in a single SIM selection of the best available network between the carriers that are available there. And then if you have a complete loss of that and you can't switch, you have the automatic switchover that's available there. So you get this really combined world of, when we talk about high availability there, a network redundancy, in terms of the coverage component, in terms of the backend core infrastructure, so you'll be able to optimize and use the absolute best coverage along with the best availability and the best performance that's possible there. I will say another component to this is the automatic switchover happens from programming that's already embedded, that's optimized based on an individual application. But like our friends at Qualcomm do, we also have the ability to have the device application, which we feel has the most information at the edge to control that switch over and switch between those profiles as they see degradation in performance, degradation in coverage, any of the, or even a preferred technology, they're able to control that at the edge. So that's what really the multi-IMSI component does. In the next slide, you see what we're seeing rapidly evolve as the evolution here. We talked about the different variations of 02, 22, and now 32. We're really seeing a massive adoption of 32 from our customer base here, where they're saying, look, I need the best of both worlds. I need this insurance policy. I need to complement. There are places like Brazil, there are places like Turkey where you have to localize with a local profile. So I need that capability of still having that single SIM where I can deploy it everywhere in the world. But I need to be able to complement that in some cases, right? That may be a rare case of Turkey, or it may be for a longevity piece where we said earlier where someone is sunsetting a network, but another network is available. I need to be able to seamlessly move on it. So this is where you see the flow profile comes in place as all of the multi-MZ stuff we talked about before, availability, the redundancy piece there. We have that embedded in an EUIPC profile that is SGP.32 compliant. So in this case, one of the things that Simon mentioned for SGP.32, you need to leave the factory with something that in this case, you would have the floLIVE multi-MZ capability within the EUICC profile as the bootstrap. And then as you leave the factory, you're deploying. If you need to make some adjustments for whatever reasons, we have that capability there to download the profile, new profile for the location that you need. And then in addition to that, it's that seamless operational efficiency where you don't need to activate or deactivate the SIM. It's just simply, you don't use it, you don't pay for it. It automatically switches over and uses the services that you need when you need it, and you pay for those services when you use it. Next slide, please, sir. I think this was also mentioned earlier in terms of the form factors, and we've seen this across, of course, the plastic is where we still see a pretty significant amount of plastics and users there. Probably 50% of our base is there. But as Simon mentioned, they're using the NFF form factor from Thales here, and we see quite a bit of that. This is like, we talked about the adoption. It's been relatively slow to move to the embedded SIM. So we're seeing a lot of customers, I think we see 50% of our customers are using embedded SIMs. In this case there, MFF2, Thales has a smaller version of this that others are using as well. And now we're seeing this new evolution where early customers are adopting the integrated SIM and evolving to that. And to some really smaller extent, the soft SIM. I'd say we've been using soft SIM for the customers for the balance of my time at floLIVE for the last 5 years, but we really haven't seen a mass adoption of that. What we're seeing now is the evolution toward the integrated SIM components, which are all supported in both the UICC form factor and now the UICC form factor as well. Next slide, please, Sarah. So when we look at kind of that piece that we mentioned earlier, the anomaly cases, and this is something that we do internally, and we're seeing this adoption of the need to aggregate the solution in reality, because when you add another carrier that's not a floLIVE carrier, it's one that you actually need, like Turkey, you then have an additional connectivity management platform that you want to aggregate, because from an operational efficiency perspective, customers still want that single pane of glass viewpoint into all of their devices to be able to have that operational efficiency that's mandatory for scale. So you can see that left here, they're able to view all of their SIMs across all of their deployments, regardless of whether it's the floLIVE CMP or the Vodafone Turkey CMP or others around the world. we're able to do that aggregation there and give that same consistency around the world, and then be able to have our support team have access to that, the customer support team to have access to that, and then unifying all the commercials. So we're still doing the commercials there, so that you don't need to extend and have another commercial relationship. Yeah, we're also built into the solution there. We have the compliance tracking. So in the case of Turkey, as an example, or Brazil, when you move into those territories, we're identifying that you're there and making the updates, sending you notifications that you need to automatically download that profile and switch over and control that lifecycle management process throughout, whether it's with the floLIVE connectivity management platform or through a third-party MNO platform there. So that last slide is really talking about what are the last SGP32 point, really talking about what we said in the previous slide, but I would highlight here that the fact that you have this comprehensive compliance from a support perspective as well, which is really critical. Ultimately, we know there will be problems. The thing that we do better than anyone in the world is empower our customers to provide that comprehensive support to their end customer. We don't own the end customer. Qualcomm, their friends, they don't want to come to us for support. They want to be able to solve their own problems independently. And because we're pulling all of that piece in ourselves from other platforms using real-time data from our network infrastructure as well, they're able to provide that comprehensive support themselves. Next slide, please, sir. And this kind of goes into a little bit more detail of what we see from the single pane of glass there that we find is absolutely critical for scale and availability. And we're pulling this in. I will say there will be an announcement shortly. So if you're looking out for floLIVE announcement, follow us on the appropriate website or LinkedIn, and you'll see an announcement coming soon about one of our partners that's expanding here to use the single pane of glass to pull in multiple connectivity management platforms, including the floLIVE connectivity management platform, to give the end customer that single pane of glass viewpoint so they can effectively manage their services. Next slide, please. Yeah. All right, so just wrapping it up here, like I mentioned at the beginning, like if you look at the fundamental of what we're trying to solve and providing multi-carrier, multi-country connectivity that's high performing, that's highly reliable here, this addition of SGP32 really enhances what we've already done. Right? We think we did the best job in the world of providing a network infrastructure, a back-end connectivity management platform for that piece that allows customers that seamless ability to really control their services there with the best coverage and best availability. Now with SGP32, along with the satellite component, we're really extending that to the next level so that customers will have the ability to provide the next level service that they're looking for, and be prepared also for things that are around the corner that we're not aware of. You know, if a new country comes out that's like Turkey that has a different requirement, it's inherently built into the solution of SGP32 to support that kind of anomaly or new situation that we need to support. So that's effectively what we do at floLIVE, and I'm here about a slide later that you want to reach out to us, yes, and connect to us. There's availability for. Thank you. All right, Sarah, if you're talking, we don't hear you.
Yeah, sorry, I was having a little technical difficulty getting myself off mute. So thanks, everybody. This was great. I have a couple of questions. We're talking about SGP32. We've been talking about it for a little while. It's a new standard. Where exactly are we sort of in the rollout of SGP32 in the wild, should I say? Stefan, do you have thoughts?
Yeah, so where do we stand? So this is new standard that has been released and worked over the past years. I think we do have everything that is required to have commercial products since let's say beginning of this year, because you need a function architecture definition, you need the functional specification. You need the certification guidelines. We're talking about an eSIM. It has to be certified. So all of this work has been done with the industry stakeholders at the GSMA in industry working groups. Everything has been released. So recently we have the full package. So that means the providers have been working on this technology for quite some time, but it's not only now that they are able to release products that are both functionally and from the security standpoint certified. So I'm talking about the eSIM. So for the servers themselves, the services, the eIM, they are also available. The certification is recommended. Is not mandatory, but is really recommended. So I think we are at the very beginning of the deployment of SGP.32. This year is really the first year we'll see the commercial solutions starting. I have to mention that it's not the first time we'll use the consumer technology in the IoT context, because some companies decided to, let's say, jump the gun to so to speak, and because they had these business issues, they wanted to solve them as soon as possible before the standard was ready. So we have seen enterprises, and we do have customers at Thales who follow this path, approximately 20, when they wanted to bring the consumer technology earlier into their solutions. So I think there's good experience on what it takes to move from the machine-to-machine technology to the SGP.32, because we had this intermediate step. So I think first year for SGP.32 is now. Volumes will start from next year, but there's already quite some experience about the technology.
Anything to add to that, Curtis?
Yeah, I would say almost all of our major customers are planning to move to SGP.32. And we've been having SGP.32 conversations with virtually every customer for 2 years. So now that we've got the standard finalized, partners like Thales are finalized their solution, getting it GSMA certified there. We're starting to see that the technology precipitate into the hardware. And I agree from what Stefan is saying from a timing perspective. We see products that'll come some or end of the year this year. We'll start to see products in the field. And then we'll start to see kind of more mass adoption and deployments for next year. And I will say, just to echo what he was saying, we see a lot of implementations that are ahead. People that went to 22 but have the ability, had some sort of user interface, they already went to 22 and they're going to 32. If you look at fixed wireless access, the SGP.22, they're moving to 32. Some of our hardware partners in that space there already have shared with us a roadmap for their SGP.32 hardware. We've seen that SGP.22 in things like VoIP applications for hotels and things like that. So in those two, we're moving to 32 as well. And then, of course, our friends here at Qualcomm and things like that are in the 32 very rapidly. Yeah, it's really interesting. I think if you see the timelines that Simon shared earlier, is we're seeing with some of this latest IoT technology. I mentioned this in the past about NB-IoT over satellite in terms of the rapid adoption of it. This is going to come faster than 02 and 22 did, simply because it's more applicable to the problems that customers and partners like Qualcomm are trying to solve.
We're getting some questions from our listeners about who owns which part of the stack. SGP.32 putting control in the hands of the end user is novel. How does it play out with all the other parts of the stack, whether it's the CMP, the SIM, the provisioning? How does that work? Can you talk to that, Curtis?
Oh, okay. I
I'll
thought you
start
were
with you
asking
on that
Steph.
one.
Yeah, look, we're very flexible in the model. You know, we built everything that we have is built on microservices, so we sell to customers what they need. Likewise, we can provide here the full end-to-end solution where we support through partners like Thales. The EIM component would be 100% run by floLIVE, integrated into our connectivity management platform to give them that seamless experience. That being said, there are two models that we're looking at here that customers are asking us for that we're providing. One is what we call an insurance model, where they don't know that they're ever going to need it, but they want it in place so that in case they do, sunset, swaps, whatever the case may be. And in that case, we're offering the ability to go to Thales and say, we want to own the EIM, integrate that EIM with another carrier's SMBP plus, and then they can move over to suites or whatever they need. The other one is a primary model where you were saying, look, I'm already aggregating multiple carriers. floLIVE is one of my partners. I know I need this in place there. And those customers are wanting to own the EIM themselves, and we're open to that model as well. Likewise, we own the EIM. There's an API set from Thales that we would integrate with that brings that functionality into our platform. Because ultimately what we're solving as well is the operational efficiency component. So we don't want them to have a separate platform that is not integrated in our connectivity management platform. So we would integrate with their EIM. It's just another instance and same API that we're already integrating with. So we make that simplified from a customer perspective. But ownership part of it there, we're flexible in the model there for the EIM components.
Stefan, anything to add?
I totally agree with what Koji said. These enterprises can decide to either own their EIM, especially when they want to combine it with their device management platform, which helps them managing the device configuration, firmware updates, etc. on the field. So it's the perfect fit because at the same time you can manage a life cycle not only of the firmware of the device but also of the connectivity, for instance. So that makes a lot of sense. If you are, for instance, a big utility company, probably this is the way you will pick actually. For the smaller enterprises or the ones who want to start with a service that is already packaged with connectivity, I think what floLIVE is proposing is perfect because you can start very quickly with SGP.32. And the insurance model is interesting. You can start with knowing that in the future, if something happens, you will be able to react. You won't be forced to go for a truck roll, change the devices, send people, that will cost you a lot. So you have this technology available. You have the connectivity. You have the EIM, which is essential to in the future, if need be, change the connectivity you have in the devices. So I think both approaches are valid. That will depend on the device, on the segment, the IoT use case, and the player.
Simon, to you, since you're building those trackers yourself as Qualcomm, which is more often known as an ingredient brand, how do you manage building the device, getting it connected, but then handing off the management to the various fleet management companies that that you sell to and work with?
Yeah, and just maybe before I answer, one definitely clarification. This is one sample device that we build, but Qualcomm still provides the most important ingredient, but we want to allow ecosystem partners to build end-to-end devices and solutions. And I think one of the key aspects, I think, to the business model that Curtis mentions, the insurance, is that as spectrum, our spectrum gets refound from 4G to 5G. And many use cases, it may be essential to provide connectivity for 10, 15, or maybe even 20 years. We've seen RFPs that 15 years of lifetime of device is essential. It's quite important to have that flexibility to move from MNO A to MNO B, as Stefan described, because you don't know what the spectrum will be in 5 or 10 years from now. And I think we are working very closely with partners to ensure that the modems and the solutions that we build on top of them have that flexibility to provide long-term life. I think this is a key aspect today, and SGP.32 is definitely one solution to enable that.
Fantastic. Do you guys have a view of what percentage of the IoT connectivity market this asset tracking application represents?
So maybe I think the three main vertical, I would say maybe within the IoT at high level, there's metering, asset tracking, and point of sale and others. I would say asset tracking is one of the top three for sure, probably in the 20 to 30%, I would guess.
Is that why you guys decided to make your own tracker?
No, I think this was just one segment to start. It's one of the most complex because you require global connectivity. And I think we always want to start with the most complex problem to solve, because then it's easier to solve the other ones. But we've hit a few cases working close with Curtis and his team that you need to track shipment going from Latin America, from Chile, where potentially maybe you have only NB-IoT coverage, and it has to go all the way to Europe and later to Japan. It's a quite complex problem, and the other sort of ingredient is low cost. To enable scale in tracking, you need a really low cost solution. It's a quite complex trade-off, and I think we dip our to solve that problem, because solving that enables to probably address many of the other verticals, and we're very focused as part of the web platform to solve all the verticals. It's sort of a horizontal solution, I would say. We just started and focused on one vertical initially, which is asset tracking.
Okay. Okay, good. Do you see particular use cases or new business models already forming as a result of the new SGP.32 standard? I'll start with you, Stefan.
I think we talked about it already. By the way, this insurance model is pretty new actually, because usually in the IoT space you get you pay either services based on the transaction volumes you want to, or you're consuming, or you pay a subscription per device per year, for instance, and it's all based on the assumption that you're going to use very actively the service, I think. But now when you project yourself on very long period of time, Simon mentioned the 15, 20 years that you can see in the utilities market metering. You have similar requirements in the automotive market, by the way, because the cars, they have very long lifespan as well. Then you don't know what the world is going to become in such a long period of time. And maybe what is very important for you, what you know for sure, is that when you want to manufacture the device and deploy it, you want to have this single SKU. So you need this technology for that, because either you use it within the factory or during the deployment of the device. First time it is powered up, for instance, and then later there are some events you cannot control. So it's more about the risk management. So the insurance model, which is new, I think is very is the answer to the question. With SGP.32, we see it coming pretty strongly, actually.
Curtis, anything to add to that?
Yeah, I think there's one at the very front, and that is like all of these SIMs have to go out with something provision from the factory. So there's a bootstrap model that I think is new, that you didn't necessarily, you either had something already personalized and you're singly locked into that carrier indefinitely. But now I think there's a bootstrap model in place that we'll see. The other thing is now, if you look at automotive as an example, automotive is really the primary adopter of SGP2. And with that, it still had the lock-in features. But I think from an automotive perspective, when you get a car and it's got connectivity, you have no choice of being able to switch that connectivity as an independent user. The carrier didn't support it. This will actually allow automotive OEMs to say, Sarah, you bought this new car, you already have Verizon, you can select Verizon if you want, instead of being locked into one of the other carriers. So I think that's one that's really interesting from a larger scale that we know is already deployed today in SGP2. That one is really interesting in addition to the bootstrap model.
I have another question from a participant. What will be the cost and commercial model to support the SGP32 SIM on top of the usage? Will there be a monthly cost associated with it? If we switch providers, will the cost be transferred? And how does the relationship between the network and the device work when we hand control over that connection from the operators themselves to the end user? Maybe I'll throw that one to you, Simon.
Oh, I'll probably toss it quickly back to Stefan and Curtis, but but at high level, I think that the SGP32 allows various business models, and I think we'll see which ones succeed in the long term. It's quite flexible solution. Which one succeeds will be business driven. And some models maybe subscription, in some models it's depending on actions. So only if you need to change from MNO A to MNO B, you pay certain fee to your provider. But in general, I think the solution allows to enable almost any business model. We'll see which one succeeds, but I'll let my colleagues that answer more in detail.
Yeah, still early days. Stefan?
Yeah, I can add to that. I would say to have this SGP32 capability, you need an eSIM functionality. It can be standalone, it can be removable, it can be integrated. We saw the form factors that are available. It's ultimately it's part of the bill of materials of your IoT device, right? So you pay for it at the beginning, and then the services that go on top, they can be provided by an independent provider. They can be bundled with your connectivity, like you guys at floLIVE are doing. So it really depends on the service you want to buy. I think the cost of the initial cost of the technology that you put in the device is not transferred whatsoever. It's part of the device cost. To be clear, what I have in mind. We don't rent eSIM products, for instance, right? So it's not a business model that we see today. But now there are different types of business models that are possible for the services themselves. Definitely. So if you, for instance, you start with a bundle where you have the connectivity and the AIM, and maybe later you want to have your own AIM, maybe you will invest in your own AIM to have it in your service infrastructure already. So maybe you will invest in this case, and then the cost will be this investment for you.
Curtis, anything else to add to that on sort of the business model? And
Yeah, I was thinking like I was hoping Stefan would say a price and says, we're gonna beat him down for half that cost. Look, I'll just give you orders of magnitude, maybe to kind of something. When you look at the physical SIM, when you look at the cost of RSP transactions, it's on the same order of magnitude as we have for SGP22. Right. SGP02 is SIM, physical SIM is about the same as 22, so not much different there, but the download fees for O2 were much lower. We're seeing download fees, transaction fees, at about the same level as SGP22. I have to imagine because of the potential scale that over time will go down to what we've seen with SGP02 levels there. And then, the new piece that we haven't explored in depth is, if someone's hosting the EIM, and of course, like that's 100% EOM providers like Thales. So we'll see how those models shake out. But I think we're still kind of on the order of magnitude that we were with SVP22. But if you look at the overall cost of ownership for the SIM, there we get into iSIM and embedded SIM. Like you're looking at significant cost savings from overall ownership, total cost of ownership perspective there. So I think it's going to be a cost-effective solution overall because of the added operational efficiency that you get with them and the flexibility, the insurance piece there. Like everyone in the industry that's been around for a little while have been through sunset. And you realize, like, look, if I could extend the life of my device out in the field with the meter, my alarm system, my car for another 9 months, like it's worth putting in that early investment. So I think it'll be a cost-effective solution on both sides.
Okay, very good. With that, I think we will close. Thank you, gentlemen, for your insights, and thank you all for joining us.
Thank you for a great discussion, and a special thank you to floLIVE for being our sponsor. You can view more webinars at iotcentral.io. Have a wonderful day.